Alright, so for this video we're going to be doing some advanced polynomial division. This first one that I have is not necessarily out of the ordinary. It's not like nobody else is ever going to see it, but it is a little bit higher than what we've been doing. It's where the number out front is different than just a leading coefficient of 1. And we might have done one that's similar to that, but I just wanted to point this out again to y'all. I've already written out my placeholders. We've already talked about placeholders, so I've already placed those in for missing terms in the original problem. So when I have a leading coefficient in my divisor that's not 1, I'm doing the exact same thing. We had a negative in one example we did. I do the exact same thing. It's just going to be that it's not just going to be 27, or it's not just going to be an x that I have to put on the top. I'm going to actually have to figure out what I multiply 3 by to get 27. So I know that 3 times 9 gives me 27, and I need 2 more x's to bring me up to x cubed. So that will give me 27x cubed, and 2 times 9x squared is 18x squared. Alright, I'm subtracting the entire bottom equation, so I'm subtracting that. This one's going to turn into a subtraction. So that disappears, and that becomes negative 18x squared. Bring down my 0. Alright, now I'm done with this part. I'm working with these two. So I know 3 and negative 18, I would need a negative 6 to make a negative 18. And I need 1 more x to bring me up to x squared. So that gives me negative 18x squared. 2 times negative 6 is negative 12x. The good thing about long division is if I'm doing it correctly, my variables are always going to line up like they should. So when I subtract, that becomes a plus, that becomes a plus, those cancel, and I'm left with 12x. Last time, I'm ignoring this, and I'm going into this one from this one. So 3 and 4 makes 12. That one has an x, and that one has an x, so I don't need any x's. So 4 and 3x is 12x, 4 and 2 is 8. When I go to subtract, I'm left with nothing, because everything matches. So again, not necessarily advanced in honors level, but I just wanted to remind you what happens when this first term or second term isn't exactly what we've been seeing so far. Okay, so now I've written down our second example. Now I want you to notice what's different about this one in my divisor. Take a minute, see if you can figure out what's different between this divisor and this divisor other than the leading coefficient. Alright, our degree has changed. So this is a degree of 2, not a degree of 1. I have an invisible 1 up there. So when this happens, I have to not only use a placeholder in my dividend, I have to use a placeholder in my divisor as well. So I have an x squared, I'm missing an x to the first, and I have my constant. So I have to put in a placeholder for that missing term. And here I have 4, 3, no 2, 1 constant. So I'm going to have to put in a placeholder for my second degree as well. Sometimes I get the question of, is it a plus or minus? It doesn't matter either way because 0 is neutral. But a plus is easier to think about in my brain. So I always use a plus for my placeholders. Okay, so I'm going to ask how many, or what I need to go from x squared to x to the 4th. Well, I need 2 more x's, and then I also need a 3 to make that match. 1 times 3 is 3. Sorry, 1 times 3 is 3. So that's going to give me 3x to the 4th. Now I have to multiply everything out, right? So that's those 2 multiplied together. Now I've got to multiply these 2 together. That's going to give me 0x to the 3rd. And then that's going to give me negative 3x squared. Now what that does is allows everything to line up how it should be. Because if I don't put this placeholder in, my exponents are not going to line up with their like terms. So here I go to subtract everything. So those cancel. This is just 2x cubed. It just gets pulled down. And this is 3x squared. I'm going to go again. I have x squared and 2x cubed. So I need a 2. And I need one more x. Because I'm at 2, I want to get to 3. So that gives me 2x cubed. 2x times 0x is 0x squared. And negative 1 times 2x is negative 2x. Bring my negative 8x down so it lines up. I just always want to keep things lined up in their rows. Alright, now I'm going to subtract. Those cancel. That becomes subtraction. That's just 3x squared. That one's going to change to be negative 6x. Alright, I'm going to go again. Oh, let me not forget my bring down that time. Because I'm working with the trinomial, I have a trinomial. I was working with a binomial, I have a binomial. That's again why the placeholder is important. So x squared to 3x squared, I just need a 3. 0x and 3 is just still 0x. And negative 1 and 3 is negative 3. Cancel. Negative 6x. That becomes a plus. So that's a positive 9. Alright, so normally we would keep going, but take a look at what's happened. There's no way to make x squared an x by multiplication. By division maybe, but not by multiplication. So this is my remainder, the whole thing. Once I can't go any farther, once this degree is bigger than this degree, I have to stop. So my whole remainder is negative 6x plus 9 over, and I want to put it over my original divisor. I don't want to put the placeholder in when I'm writing out my final answer on that. Now we could go even deeper into this as far as simplification goes. This one is not going to simplify. That's more of like something you might see in college. I'm going to steal my sticky note and show you, just so I wouldn't make you do this. But I want to show you what I'm talking about when I say simplify my remainder farther. Throw back to factoring that we did. Once we get to pre-calculus, we're going to have to review factoring again. But if I factor out a 3 on the top, and this is a perfect square on the bottom, I can write my remainder in factored form. And then if my parentheses were to match, so let's say I had something like this. I don't, but let's say I did. If I ended up with something like this, those parentheses would have been able to cancel out. So I'm just telling you that because we're not there yet. This is more of a pre-calculus thing. But as you get into higher level math courses, especially in college, they might ask you to simplify that farther if possible. Now simplifying it, or factoring it, didn't help us simplify any. But that's why when we learned factoring, I told you guys that it was fundamental to a lot of things that you do. So there's that for a little bit of advanced long division simplification. So that's one of the big ones I wanted to show you. So take a gander at that. Pause it if you need to. All right, here's our last one. Just ignore this. I wrote it down and then I realized it was just a monomial division. And I don't know why my brain thought that it was something other than a monomial. But this is the last one we're going to work on. It has a fraction in it. Okay, so we're going to proceed like usual. I've put in my placeholder. Yes, you have to put a placeholder in even if the constant is what's missing. It helps you stay aligned. So to go from x to 2x to the fourth, I need 2x cubed. That gives me 2x to the fourth. And negative 2 times 2x cubed is negative 4x cubed. subtract. That's going to give me, I'm going to keep it in improper form. Yeah, I'm going to keep this in improper form. 9/2 x cubed, bring down my x squared. The reason I'm keeping it like this is because improper, I can at least pop in my calculator in a minute if I need to. All right, I'm going to keep going. X into 9/2 x cubed. I need a 9/2, and I need an x squared. So that's 9/2 x cubed plus, nope, it's going to end up being a minus. -2 times 9/2 is a -9 x squared. Subtract. Those cancel. 10x squared. Just take a look one more time. I had 1/2 and 4. That makes 4.5, which is 9/2. So to go from x to 9/2 x cubed, I needed 9/2 x squared. And I subtract the whole bottom. Now the reason why this was 9 is 9/2 times 2, I can cross simplify, and it just becomes 9/1. Bring down my x. X to 10x squared, 10x. That gives me 10x squared minus 20x. Subtract. Bring down. We're in the final stretch. X to 21x, I need a 21. That gives me 21x, and -2 times a positive 21 is a -42. Subtract. There's my remainder. Remainder over divisor. All right, so there's your notes on advanced examples. Again, ignore this one. I just had a brain moment. So 3 things. I reviewed over what happens when your coefficient's not 1. What happens when your degree is not 1. This is really the bulk of what you need to look at. And then what happens when we have a fraction. Again, we're going to want to keep it in improper fraction and not work with mixed fractions. All right, you're going to have some practice on these that I'll post to LMS in the upcoming days. And I'll also have a copy of these notes for you guys.